So you do everything from the computer? Or
Yeah, that's right, Rich. So we basically plan it, the GPS coordinates on the computer, and then we plug it in with the USB. And then the drone operator basically needs to launch the drone safely, get it airborne up to the target altitude, and then we hit start, and the drone heads off on its way and basically gets overhead its first waypoint and then starts taking its shots. So we set the overlap manually depending on what sort of accuracy we need. So the more overlap we have, the more accurate data we can achieve. I guess the byproduct of that, it's a little bit slower, so we've just got to balance that depending on the site. And then once we sort of run out of battery power, then basically we bring the drone down manually. We then change the battery, relaunch, and hit continue, and it'll fly back to its last waypoint and continue again. So,
fantastic, sounds good.
no, have a look. The N variant, the one we've got, I can't remember exactly what it's called, but yes. So, that out.
That's a nice little machine there.
It is. It is. It's a Aztec Falcon 8, very reliable. We got that from overseas. Actually, position partners, so the Black Legend. This is our control system.
Yeah.
And let's go get our batteries.
We're currently getting the drone ready, connected up, checking everything, ready to get her airborne.
Get it up to a safe height, and then we can continue, acting like usual. So
Yeah.
the main thing is just obviously safety comes first. So we'll get it up to that safe altitude, and then from there, we'll commence our demonstration, what we're sort of looking at today. I'll have a bit of a chat to you about it.
Yep.
No worries.
All right, so
Very good.
We'll get back a bit further.
Yep, great, thank you. Okay, so we're all clear? Yep.
So we see her doing her own thing up there.
Yeah, so it's going over now to its waypoint, which I've set in the system, and then it will commence starting photos and starting the photo run to get the overlap happening. Okay, so you can see it up there now, so it's approaching point 1. And once it's at point 1, it'll basically get itself set within about 2 meters accuracy in the air, and then it'll start taking photos. We've set 80% accuracy here in the vertical, and 75% accuracy horizontal, which should give us some accurate results. And so from this point, it's really just about monitoring. So I need to keep my eyes on this at all times legally, and so it's very much a visual line of sight flight. And so I'll refer back to the monitor briefly just to make sure everything's okay, but otherwise eyes on the UAV, and then once it gets close to the battery change, I'll hear an alert and basically bring it in manually to land, and we'll send it back up again and continue from the last point.
Oh yeah. Oh yeah, okay, so it goes from point to point, takes a shot.
Yes, yeah, so it sits in the middle of that point, gets stable, takes a shot, then continues to the next location.
I'll try to get it on my
Yeah, a bit hard.
zoom
Away
here.
from the sun there. UAVs can take less, it just depends on the design, and also with your accuracy, when the wind basically tilts the UAV, uses photogrammetry. So basically each photo is encoded with a lat, long, an altitude, and then it will also have pitch, roll, yaw. And from that, we then basically plug all the photos together, and we use a software program that really accurately stitches the photos together. And it's able to judge basically each individual pixel. It gives it a location in space.
Oh yeah.
And it compares the pixels in each photo, and then is able to tell basically, if the height's changing, or if we've changed lat long or lateral sort of separation. And once we've stitched everything together using this program, we come out with a very accurate 3D model. And based off that model, we can then accurately measure basically, point grids. We can get slopes, we can get elevations, measurements in terms of road slopes, distances. And we're finding the accuracy is down to around 3 or 4 centimetres. Sometimes better depending on the location, but definitely within 5 in most cases, which is on par with a lot of conventional surveying standards. With the advantage that you can accurately get slopes because you've got a 3D model there to work on.
Yeah. You're not doing too much triangulation there. You haven't got a grid. You've got actually each pixel is.
Yeah, that's right. There's that signal. So you have each pixel, but then from that you develop a triangulation or a grid, so you can actually pull that from there. So you really get too much data. Yeah. And then
she's coming back now for battery change.
That's right, battery change now.
So we walk back a bit.
Stay clear, guys, if we can.
$70,000 worth of hardware and landed. Beautiful.
Alright, we're clear here, yep.
They're all good. So we've got some issues with overheating computer at the moment. But
Just check that front cover. This side.
what's the reason there?
I don't know, sometimes it might just be signal
Oh, yeah.
shielding, but